Math 2414 Improper Integrals, Discontinuous Integrands, Example 3. This will be the last video in this series. Looks pretty harmless. The integral from 0 to 3 of 1 over x minus 1 dx. Now, this is an improper integral because the integrand has a discontinuity and we're integrating right across it. Where is this function discontinuous? This function is discontinuous at the value that makes the denominator 0, x equals 1, which is right smack dab in the middle of 0 and 3. Now, if you didn't catch that discontinuity and try to integrate it as is, you would not only get an answer, you would get a wrong answer. So how do we integrate over an interval that contains a discontinuity inside somewhere? And the answer is you stop at that discontinuity. So we're going to start at 0 and stop the integral at 1, plus another integral that picks up from there, so 1 to 3 of 1 over x minus 1 dx. And we have to tackle each one of those separately. So let's start with the integral from 0 to 1 of 1 over x minus 1 dx. And keep in mind that 1 is a problem. We handle problems and limits of integration by replacing them with a variable, doing the definite integral, and then taking a limit. So we're going to start this one by saying the integral from 0 to t of 1 over x minus 1 dx. This antiderivative should be pretty transparent. It's the natural log of the absolute value of x minus 1 from 0 to t. We substitute t, we get the natural log of the absolute value of t minus 1, minus, if we substitute 0, we get, well, let's go ahead and do it. Minus the natural log of substitute 0, we get x minus, 0 minus 1 is negative 1. But the absolute value of negative 1 is 1, and the natural log of negative 1 is 0. So the second half of this subtraction problem vanishes. So there's our antiderivative. Then, we have to take the limit as t approaches the correct number from the correct side. We are approaching 1, but this integral was from 0 to 1, which means our t is somewhere between 0 and 1, which means to approach 1 means to approach it from the left. So the limit as t approaches 1 from the left of the natural log of the absolute value of t minus 1. All right, let's think about this for a second. As we're approaching 1, the subtraction problem is approaching 0. So we have to think about, and I haven't done this lately, but I'm going to draw a thought cloud. As t approaches 1 from the left, this is approaching 0 from the right. Why do I say from the right? Because this is always positive. Positive numbers are on the right side of 0. So the question we need to answer here is what happens to the natural log as you approach 0. I know we're approaching 1, but 1 minus 1 is 0. So as this approaches 1, the log's argument approaches 0. Well, this is where knowing the graphs of your functions comes really in handy. The graph of natural log looks like that with the vertical asymptote at 0. This guy is plummeting to negative infinity with an absolute value. So we have the, never mind. This whole thing is plummeting towards negative infinity. The absolute value happens on the subtraction problem, not after the log has happened. So log's going as you approach 0, so this is approaching negative infinity. So what does this mean? Well, it actually means the problem's over. Because in order for this to exist, these must first exist and then get added together. But if they don't exist, then neither does that. So that integral doesn't exist, and this problem is technically over. Now, if we did the same thing here, we would get the natural log of the absolute value of x minus 1 from t to 3. And so when we plugged in the 3, we would get natural log of the absolute value of 2 minus the natural log of the absolute value of t minus 1, and we would get the same thing here. So neither one of those exists, so this is over. The integral from 0 to 3 of 1 over x minus 1 dx diverges. So great, we split into 2, one of the integrals was bad, the problem is over. So what's the big deal? Well, here's the big deal. I mentioned at the beginning of this problem that if you didn't catch the discontinuity in the middle, you would get an answer and it would be wrong. So what I'm about to show you is the wrong thing to do. If you had not caught the discontinuity, x equals 1, in the interval, this is what would have happened. So I must emphasize that what I'm about to do is wrong. I don't want somebody to watch this or get frozen on the screen on YouTube and go, oh, that math guy doesn't know what he's doing. If we did this without pausing at 1, the antiderivative is still the natural log of the absolute value of x minus 1 from 0 to 3, and this can be worked out. Substitute 3, substitute 0. 3 minus 1 is 2, and the absolute value of 2 is 2. 0 minus 1 is negative 1, and the absolute value of negative 1 is 1. Natural log of 1 is 0, so we would get an incorrect answer of the natural log of 2. The reason this happens is because you accidentally glossed over the discontinuity, which would have set up, well, it's kind of like an infinity and a negative infinity canceling, except they don't. So, yeah, that didn't make sense. Just pretend that last part didn't happen. All right, so my point is, if you are integrating over a discontinuity and you miss it, you very well could get the wrong answer. You might get the right answer, but you might get the wrong answer. And that wraps up this series of videos.